Hey everyone, welcome back to another Bertrand Math. Today we are dealing with set notation, intersection, and union. Get that notebook there because we got a lot of vocabulary coming your way. Okay, hey y'all. So welcome back to Bertrand Math. So today's lesson, which centers on set notation, intersection, and union, which is tied to homework number 3, isn't, in my opinion, heavy on the calculating side, but there is a lot of vocabulary and understanding of numbers and that goes into having good number sense. So today we're going to be doing some, I would say on your notebook, create some space where we're not necessarily just doing vocabulary and problems, but give some space for diagrams, drawing, like arrows and stuff. You'll see what I'm saying in a second, because the notes that I want you to take in terms of what we're talking about today may look a little different than our traditional stuff. So let's just get into it. So this idea of sets, and here we have, oh, let me get the lights. And here we have 3 different types of sets, if you will. We know it's, and this one here is called set A, set B, and set C. We usually use brackets to denote, or some type of, I don't want to say parentheses, but I'm going to go ahead and say brackets to denote that this is a set. So set A contains the elements, and everything inside of this. I'm going to put a little arrow here for elements. Each one of these is an element. So set A contains elements 1, 3, 5, 7. That's one way to write it. Sometimes you'll see sets written like this because the number of elements is actually pretty small. There are other cases where the element actually gets a little bit bigger, and no one has time to write all that. So to interpret this, you see a bracket, an X, and a bar here that actually translates to something. And it translates loosely to such that. So the way we read this is set B is X such that X, right, are numbers less than or equal to 7. So if I'm thinking about numbers or all values, think about that. All less than 7. That's a lot. And if we started including even like negatives, right, that's tremendous. And no one has time to write all of that. So here's when you have a few elements, right, you write it all the way out. And then we have a notation, if you will, where we can write really long ones in just a few syllables and numbers. The reason why I point out set C here is because sets aren't just numbers. Right, we dive into this whole year. We'll be diving into a lot of word problems and problem solving, and so we go beyond numbers. So sets can also be other things like fish, birds, chickens, things of that nature. So I just want you to get an idea here of all types of sets. Now going back here to this element thing, I want to show you another notation. You'll see this written like this. This is the symbol for elements. And the way we read this is 3 is an element of set A. Right? I could change this. 1 is an element. Now, if I wanted to answer this question whether true or false, I say something like this. Well, we know 10 is not in this set, so you would see that, and that would be not an element. The symbol isn't necessarily an E. It kind of has that curve to it, so you're like, well, why is he drawing it that way? I want you to know that is not just my penmanship. That is intentional, right? The element has that kind of arc to it with it, E there, and you'll see that in the homework what that symbol is. So it's either an element or not an element. Okay. One other thing, let's go back to set B and A here. I want to show you a little something. Okay. So again, we read set B as x, all values of x such that x is less than or equal to 7. Well, interestingly enough, all of the 4 elements, right, in set A actually can fit, if you will, can fit inside all of these possibilities. So this is where we introduce this idea of subsets, right? That is what I want you. So, right, we've talked about, and I'm stopping here, right, because I'm giving people time to really organize their notes. We talked about the ideas of sets. You should have captured that. You also should have captured, what's the other thing we talked about? Elements. Yes, you should have captured that somewhere, elements, and wrote down, or at least make sure you understand that sets can look really long, can look really short, and they don't have to just be numbers. Now we're talking about this idea of subsets, which of course has its own symbol. So since we know we can fit all of A into B, we write it as like this. A is a subset of B. Now, don't interpret that as just ACB. No. I'm not doing it justice, but you'll see in the book does it better. It really looks more like a U. Like a U like this. Yeah, I think that might be better. And sometimes you'll see it with a line under it. It means the same thing. It's just like you might pronounce it tomato, I might pronounce it tomato. It's kind of like that. So it is still this idea of A is a subset of B. The line is, irrelevant. You'll see it either way. So either see it like that or like that. Obviously, if I said, for example, let me create another set. So let's just have to kind of what we're working on here. Let's say there's a set C. And this is 3 elements in set C. Well, can you tell that set C has nothing to do, has no connection to set B? So then I would write, if I wanted to, if I asked the question, is C a subset of B? That answer is no. So you'll see it that way. I know sometimes we're used to maybe seeing like cents, like when we talk about money this way, but this is the other symbol, right? Do not confuse subset with elements. Huh? Remember that? It's kind of like this. I know, right? It can be so similar. Be super careful with that. All right. Not bad. We're doing great. Now, I want to just, since we're talking about numbers, and in this section of the unit, we're going to be talking about all types of numbers. And this idea, we're going to do a little review here of like, what are natural numbers? And in this section here, in your notes, I want you to put something, right? We're going to capture all of these numbers and how they're connected. This should kind of feel like a review. I think you might have touched on this in 6th grade, but this is uber important to literally the rest of this unit. So we got to go through the different types of numbers we're going to be dealing with that we kind of already know about. And actually, I'm going to do this a little differently. So in the middle here, natural numbers. And natural numbers are the numbers you see in nature, the numbers that we all know, right? Like 1, 2, 3, 4. We get that. Then right? Those are our natural numbers. Now, outside of that, we have our whole numbers. And I'm going to show you a better graphic as soon as I get done with this, right? But you can build this out with me. Our whole numbers are here. And the only difference is that we include this idea of 0. So 0, 1, 2, because it's math, right? Math is all about the positive and the negative. It's all about the balance. That's why the equal sign is there. So it's the same thing. So just as we can identify something that is whole, right, we also can say something that represents when it is not, it is completely not whole, which is 0. The reason, right, natural numbers deal with nature. So you can't hold 0, yet it represents an identifiable value in this sense, okay? Next, outside of that, we have integers. Integers. This is where we introduce our negative whole numbers, if you will. Our -3, right? -2, -1, and including whole numbers 1, 0, 1, including natural numbers. I think you kind of see where I'm going here. I promise it's going to get a little crowded on here, and I'm sorry about that. But you kind of get where I'm going in terms of the different kinds of numbers you'll deal with. Oops, I drew that bad. Sorry, my tech went down for a second, but we're here. We're almost there. Rational numbers. Rational numbers. Now we're including, right, our fractional ones. Now we're talking about if an integer can be divided by an integer. Now that we're getting into positive and negative numbers. Rational numbers can be decimals, but they are either terminating or repeating. If you remember that, repeating. Now, if you're not sure, like terminating decimals, repeating decimals, go look it up, right? You have seen these 1,000 times, 1,000 times. Almost there. Then we have this tale of irrational numbers. And I want you friends to be creating some type of diagram, and I'm going to flash one up on the screen in a second here. Let me get it tight, get it set up while we're talking to show you exactly, to highlight what I'm talking about here in case mine doesn't work out here. But irrational numbers are the ones where we have decimals. They're the really weird numbers that don't have any pattern in their decimals, and they never end. We call those, right? Our most famous one is pi. Right? It's the decimal that will never end, and there really is no rhyme or reason to it. And then, right? So we're almost done here, right? So we're looking at the natural numbers here. Boom. Then outside of that, we have whole numbers. Building outside of that, we add in the integers, the negative whole numbers here. Then we have rational numbers, terminating and repeating decimals. And then we have irrational numbers, decimals that don't end. And then really what this is real numbers. We call these real numbers. Now, the reason why this graphic didn't do it justice because, right, irrational is like, it's like over here, if I could, it's over here in its own world. Right, so you can't, you'll never have, let me just show you the graphic. I think the graphic does it much better. And I can speak to it better here. So, right, so you, in the center of it, you see, there you go. You see you have natural numbers, those was right, 1, 2, 3, 4. You add in the whole number there, right? In that circle, integers, the -1, -2, -3, that. Rationals, terminating and repeating decimals. And then over here, because irrational really is that irrational. They're like crazy, just overtly crazy decimals that never end. And there's a few popular ones. All of these All of these are real numbers. And we literally call them real numbers. Now, it's gonna get a little bit more complicated. And you're like, what, Mr. Bertrand, it's gonna get a little bit more complicated? How so? Okay. Well, let me show you here. You will see natural numbers. You'll see natural numbers represented by the big letter N, W for whole numbers, excuse me, Z for integers. I know, you're like, what? We just do it this way. Q for rational numbers. I for irrational numbers. And I'm going to make it tight in the space here. Sorry, friends. And then, believe it or not, R for real numbers. Meaning, you could see a notation. For example, if I ask this question, I said, I'm going to actually bring up the graphic. So if I ask, going back to this idea of subsets, are whole numbers a subset of integers? What would that look like if I wrote that question out, right? Are whole numbers a subset of integers? It would look something like this. Right? Keep that graphic in your notes, in your mind, right? Keep it right there. Are whole numbers a subset of integers? Well, if you think about it, are whole numbers inside this idea of integers? Yes. One more time, going back to the graphic. Now, what I want you to see in that, right? Whole numbers you find inside of integers. I asked another question, right? Are rational numbers a subset of real numbers? Are rational numbers a subset of real numbers? That answer, yes. Got it. Now, are irrational numbers a subset of natural numbers? Are irrational numbers a subset of natural numbers? That answer is no. All right, you get the general idea. You got it. I think you got it. Now, we got one more thing to show you, and it's actually going to go pretty quick. This idea of intersection and union. Give me 2 minutes and I got you. Let me go back to my dual phone. Okay. If I said meet me, and technically any of these could work, but I'm going to put myself right here. If I said meet me on this corner, pretend this is a map, right? This is First Avenue, this is Avenue A, this is Avenue B. Now, let's say I wanted somebody to meet me here. We would say, at least us New Yorkers would say, meet me on the corner of First Ave and Avenue A. Now, knowing us, we would say the Northeast Block, Southeast Block, but when you know that, right? So when I say meet me on First and Avenue A, even though I mean here, it does limit my location spots, right? There's 4 places. That's First Avenue and Avenue A. Now, where this gets crazy is if I told my friend to meet me on First Avenue or Avenue A. Think about all of those possibilities. If I said First Avenue or Avenue A, it's like, oh, right? It could just go on forever. And that essentially is the difference between union and intersection. The and the or. So, let's say we have a set, and the elements of set A are 0, 1, 2, 5, and 7. And I have a subset, a set that is B, 0, 2, 3, 5, and 8. Tell me, and we represent union by the symbol of a U, and we represent intersection as like this down, right? It's not really an M, but it's like a down U, a upside down U. But let's say I wanted to know union, which for us means or, right? An intersection, like we were talking about at an actual intersection, is the and. So if I wanted to know now, I know you're thinking about this, right? What elements? I want the elements of A or B. Huh, okay. I want the elements of A or B. Then that would be what? Be 0. You don't have to put it twice because it's there already. 1, 2, 3, 5, 7, 8. A or B. Making sure that I have all the elements of each. No copies. That's not necessary. Now I should switch A and B. Which ones do they only have in common? Well, if I switch that symbol to something like that, what do they have in common? 0. The 1? No. 2 exactly. And then the 5. And that's how you write your answer. So, friends, we have walked through what sets are, what elements are, what subsets are. Really thinking about numbers to help our number sense, right? Natural numbers, whole numbers, integers, rationals, irrationals, real, all of that. And then we brought in this idea of union or versus intersection and when we are comparing sets. All right. Well, I'm going to stop right there. You hung out with me for a while now, but give it a shot. Let me know. Try homework number 3. Let's be in touch. I'll see you in class. Have a good one. Thanks for being with me.